Okay, so example 3 of projectiles is going to cover what happens when we project an object at a speed that has an angle that is not just to the horizontal. So this one is having an angle of 30 degrees. So let's just start by drawing a little picture. So you've got the object that's being sent up, the speed is 28 meters per second, and if we draw, this is the ground, it's being projected from the ground, we can draw in the angle, which is 30 degrees, and then we can draw the arc of the object that we'd expect. It's going to come up like that. Should be symmetrical, apologies for the non-symmetrical drawing, but that is symmetrical, it's a symmetrical motion, and it will always be, as we're going to see in the 4th lesson. Right. We can, like all the other questions, we can do two things, and there are the only two things that we can do, and one is to resolve it and do suvat vertically, and the second is to do suvat horizontally. So if it's asking us for the greatest height above the plane reached by P, that's asking for us this height, and that's going to be a vertical suvat, because we're looking for a vertical height here. Height is vertical, so if it's asking for the greatest height, we're going to use suvat vertically to attempt to find that point. So the first thing is we need to start with the initial velocity. So the initial velocity is 28, but 28 isn't going straight up. 28 is going to that way with an angle of 30 degrees here. So if we imagine where the vertical is, we can see the vertical would be this orange dotted line, and in order for us to get to it, we would have had to move away from the 30 degrees, and if we are moving away from the 30 degrees, then that is going to be sine of 30. The acceleration, because it is vertical, is minus 9.8, because I've taken the upwards direction as positive, and the acceleration is always 9.8 vertically towards the ground. We are trying to find the greatest height, so we're looking for S. And then the other thing that we have is the velocity, the final velocity. And the reason that we have that is because we know when it's at its greatest height is going to be the turning point of the trajectory. So it's got a positive velocity up until that height, in which time it starts coming down, so the velocity will go negative. Therefore, when we've got the turning point, the greatest possible height is when v is equal to 0. It's no longer going up, and it's about to start coming down, and that'll be the greatest height. So we've got enough to solve it, so we put all those into our equation. It'll be v equals u squared plus 2as. Obviously look for those in the formula book. We should also work out what 28 sine 30 is before we square it, so let's do that on the calculator. 28 times sine 30 up there, that's actually just 14. So this is 14 squared plus 2 times minus 9.8s, which is what we're looking for in this case. So we can rearrange it. This is minus 196 divided by minus 19.6, and that will give us, when we divide them, a value of s of 10. Okay, so 10 meters is the highest point when it starts to come back down again. It then asks for us to find the time of flight for P. So it's all about then when it lands. So what do we know about when it lands? We have to think about this. Do we know anything about the horizontal, or do we know something about vertically? Well, we know that the horizontal, well, we don't know anything about horizontal distance. What we know is the vertical height. This is then 0 meters above the ground. So vertically, we started on the ground and we finished on the ground. So the displacement, which is s vertically, is going to be 0. So again, we're going to resolve it using the vertical direction. This time it's going to be s is 0, u we know is 14, a is minus 9.8, and this time we're looking for the time. So we want to find the time where it's come back down. So again, what we're going to do is we take a formula from suvat, so this time it's going to be s equals ut plus half at squared. So we've got 0 is 14t plus 1 half times minus 9.8 t squared. So this is 0 equals 14t minus 4.9 t squared. We can factorise out a t, 14 minus 4.9 t. This will then give us two answers, the one from this side, which is t equals 0, and now on the other side, we're going to solve that equation. So that's equal to 0, so that'll give us that 14 equals 4.9t, So 14 over 4.9 is our value of t. Okay, so this is 2.86 seconds to 3 significant figures. Okay, so that's part B, the time of the flight of P until it hits the ground again. Then the final is the distance OA. So O was our point of projection here, and A is the point in which it lands. And we're looking for this distance. So as you can see, that's a horizontal distance, so we're going to use SUVAT horizontally this time. And we need to work out what we know. So again, we know the initial velocity. This time though, because we're doing it horizontally, right, U is not 28 sine 30, it's 28 cos 30, because we've gone through the angle of 30 to get to there. We also know that T is 2.86, right? We know that from over here, right? We found that it landed at a point 2.86, and we're trying to find the distance when it landed. So we're looking for the distance after 2.86 seconds. So S is what we're looking for. And finally, because we're going horizontally, we know that A is 0. Right, that's what we did in the first lesson of this unit. We said if we're going horizontally and we're doing SUVAT horizontally, the acceleration will always be 0. So let's find out what 28 times cos 30 is. Okay, it's 14 root 3, or if we use the decimal version, 2.857, and then a bit more. So all I'm going to do is I'm going to use my equation. So I've got S equals UT plus 1/2 AT squared, but our A is 0, so this 1/2 AT squared term is going to die, and we're just left with S equals UT, so it's our 28 cos 30, 2.857, times 2.86, but again, you see both of these are previous answers, so I use a ... to show that actually I'm going to make sure I'm using my full accuracy. So to get this answer, I'm going to type it in again, and with my T answer, I'll type that in again, and then what I'll be using will be the full calculator accuracy. So I've got 14 divided by 4.9, and then I'm just going to times it by 28 and cos 30, right, to give me the most accurate possible answer. And it's 69.3 meters. So that answer is to 3 significant figures. They want you to round it. It's either 2 or 3 significant figures. I'll always use 3. But throughout the question, we need to try and use full accuracy wherever possible.